Hi, this is Mark Weitzman. This is version 2 of the of my playlist on textbooks for physicists, physics students, and this is the second one on quantum mechanics. So there are like a large number of books on quantum mechanics, and I'll give you my recommended ones, many of them in this video, but probably depending upon where you are, if you're at like freshman or sophomore level, you might want to start with something like Volume 3 of the Feynman Lectures on Physics. Feynman pioneered a new way of teaching when he taught the Feynman Lectures on Physics, especially for quantum mechanics, where he taught things like probability, spin 1, and spin 1/2 to begin, and only later in the book did he get to the Schrodinger equation and the hydrogen atom. So it's a very good treatment of spin, and it might be a good place to start if you're a beginning quantum mechanics student. It's not a textbook per se, but I would, and there are exercises which test this stuff. We talked about that in video 1. Now, another thing that one can do is, before I took a quantum mechanics course, I took a course that was Principles of Quantum Mechanics. It's an old book by Layton, who was at Caltech. At that time, it was actually given to seniors, but it covers an awful lot of quantum mechanics, where it starts with relativity and then it goes to, the Schrodinger equation and atoms, molecules, nuclei, and elementary particles. And it covers things like X-rays, topics that are often ignored nowadays as we have to push things earlier and earlier into the curriculum. So this book covers like holes. Now, what you need to do as a student is to find an updated version of this book. There are many modern physics books out there, and I haven't looked at them. So find one that's good, that's like a little past freshman level, not much past freshman level, and take a look at it, and maybe it can do the holes that a lot of quantum mechanics books don't treat nowadays. They sort of go past it. Some do, some don't. There is an excellent book on on modern physics that was published a couple of years ago by Steven Weinberg, who recently passed away. But this book is a little bit too advanced. It starts in the beginning. I might have written a review about this book. It starts in the beginning very good with like early atomic theory and how they measured things, and thermodynamics and kinetic theory and all of this stuff. But then and the early quantum theory, but when it gets into relativity and quantum mechanics and wave nuclear physics and quantum field theory, you really would have a hard time understanding this unless you've already had a quantum mechanics course. So I actually recommend reading this book after you've taken a quantum mechanics course, not before. Now, since I made this video, Barton Zybeck's book on quantum mechanics has come out, and I recommend this above all other books for a beginning student. The book is based on notes for the 3 MOOC courses that I was involved in in the discussion forums, and that was run by MIT and edX. And they have video lectures online at MIT OCW, and eventually this course will be run again on an MIT site. And so it's a great way to get a book that closely tracks a video course with exercises, problems, solutions, and exams. But I wrote a review of this book on Amazon, a very long review. I think I'm still the only review on it. But you can see how long this review goes. So you can read more details about it. What I like about this book is that it's really like 3 courses in one. It starts out with what's like a sophomore level course on quantum mechanics. And you can look on the table of contents and see that this covers, your basic things on quantum mechanics up through the hydrogen atom and everything. It finishes with spin. But it doesn't do the theory in detail, and it doesn't do perturbation theory and various other advanced topics in detail. This is in part two. Part two and three are like after you've had an introductory course in quantum mechanics at the sophomore level. It's a rigorous full-year course, like given by Caltech and MIT and other top institutions where they have 3 semesters on quantum mechanics. And so the theory is given in volume 2 and some of the applications. And then in volume 3, it covers really advanced material on like scattering, the adiabatic approximation, WKB. It does perturbation theory like the best I've ever seen it, degenerate perturbation theory. And there's a chapter on density matrices, and it's thoroughly modern, this book. Things about Bell's inequalities, quantum computation, cryptographic applications and everything. They're all included in this book, the BB84 key protocol. So it's really an updated quantum mechanics book that still covers the traditional material. It's 1,000 pages long. It's, in a sense, 3 books in one, but I highly recommend it. And you can read my review on Amazon. This is definitely, if you want a quantum mechanics book and you're a student, this is the one to start with. One of the main, at least graduate level quantum mechanics book, I should probably have this later in the thing, is Modern Quantum Mechanics by Sakurai. I haven't read this book. It gets very good reviews. I've seen some problems from the book, and they're very good. The only thing I can say is that Sakurai died before the book was completed, so it's not really written completely by Sakurai. And it seems to be more of an outline of a book than a detailed presentation like some other graduate level quantum mechanics books. But anyway, this is used in many places. And you shouldn't confuse this with a great book that Sakurai wrote all by himself called Advanced Quantum Mechanics, which is really extending quantum mechanics to the relativistic domain and also quantum field theory. So this is an excellent book to read before you begin your quantum field theory studies. Other standard, this is probably the most loved book on quantum mechanics by Griffiths. It's an excellent book. I have read it. The main problem is it doesn't go deep enough. It uses, it talks about Dirac bracket notation, but then it doesn't use it. It's mostly a wave function book. But it's got some excellent chapters, and he writes very well. And the other thing is that he just presents the Schrodinger equation on page 1. He doesn't even attempt to give a motivation for it or a derivation or something. But there's a lot of things in this book, and students seem to like it. Usually when students like a book a lot, it means it's easy. And I suspect this book is relatively easy. And I think the 3rd edition has been updated a little bit to EPR paradox and various other things, mixed states. So this is an excellent book, and if you're using it in a course or if you want to read it, I recommend it. The second most popular quantum mechanics book is a book by Shankar. This book is Principles of Quantum Mechanics. It's an interesting textbook. The author is like, his main research area has to do with path integrals and condensed matter. And he's got several chapters, like Mastering Quantum Mechanics doesn't treat the path integral. It leaves it to graduate level. But this book treats the path integral in several places, in addition to a long final chapter. But he's got an excellent, very good linear algebra review for about 60 pages at the start of the book, which is fairly good, and he reviews classical mechanics. So if your physics is a little weak and your mathematics is a little weak, this is a really good book for reviewing a lot of stuff. And then he has several chapters. He has a chapter 8 on the path integral formulation, and then at the end of the book he has a very long chapter, path integrals, like about 70 pages on imaginary time formalism, fermion and spins, and various other things. So I like Shankar a lot. I think the book is a little weak in the problems. He doesn't have enough of them, and he interrupts the chapter's flows with like exercises and derivations which aren't really too good, and he definitely needs more problems in the book. So that's the weakness of this book, in my opinion. The strength is that final chapter on path integrals. The next book is a more of a reference book. It's been a long time referenced by Claude Cohen-Tanuji. It used to be two volumes and 1,500 pages, but after about 40 years, they finally came out with the second edition. So there's this second edition, and I don't think too much has been updated in the first edition. The volume 1 is the basic concepts and tools. These books are expensive. That's, well, maybe not that expensive, 66 to 140. So, but they're, if you want a textbook that does like the harmonic oscillator in 1, 2, 3 dimensions, in rectangular, spherical, and parabolic coordinates, this is your book. It's really a reference book. It sort of does everything in every different way. It's written in a little bit like the French style, a little not that exciting, but it stood the time as a reference book for undergraduate and graduate level books on quantum mechanics. And now the second volume treats angular momentum, spin, and approximation methods. And then there's this new third volume, which looks really interesting. Oops, sorry. Where did I go? Okay. This is the volume 3 of Cohen and Tanuji. They added a whole new problem on fermions, bosons, photons. This is really a condensed matter and entanglement. So this is a little bit beyond your quantum mechanics course, but it has a lot of interesting things in here. It's more of a condensed matter. Now, for graduate level text, two other textbooks I want to mention is Walter Greener has a whole theoretical physics series starting with quantum mechanics and going through all the way through the standard model. There's probably about 10 to 15 volumes in the series. And they're all sort of like a workbook series. I really like them because he has a lot of detailed calculations and examples that you just don't see anywhere else. You know, everywhere else they sort of like shorten the presentation, but he gives a long presentation. And this volume, the first volume, Introduction, is very good, but he also has 2 excellent follow-up books. Quantum Mechanical Symmetries is more on group theory, and I'll have this in my group theory playlist. And then he's got another follow book on special chapters where he treats all kinds of things on quantum statistics, structure of atoms and molecules and everything. Again, he's got like 72 fully worked out examples and problems. So this book doesn't have really like problems. It works them out and solves them for you. And it's very detailed calculations. And I sort of really like learning from his books. It's not that great as a reference, but it is really good to learn from them, and these special topics are very good. So that's Greener's like workbook series. Now, in terms of graduate level quantum mechanics book, this is my favorite one, Quantum Mechanics by Ballantyne. Get the latest revised edition, second revised edition. He added a whole new chapter on like 70 pages on quantum information. But it's a really excellent book. He has a whole chapter on Bell's theorem as well. But what I really like is his chapter 19, Quantum Mechanics on the Electromagnetic Field. It's not the usual quantum field theory treatment. It's a non-relativistic treatment of photons and correlation functions and coherence, things you take in a quantum optics course. And he has a similar chapter on many fermion systems as well. So the treatment in here is sort of advanced, not too advanced. It's not functional analysis writ large, but he covers a lot of things that you don't cover, the edge cases, the exceptions, things that sort of get neglected, like transformations on kinematics for the Galilean transformation, non-relativistic quantum mechanics, things like that. He does really, really well. So as a graduate level quantum mechanics book, it's not too long. It's about 600 pages, and this is where I would start. Now, there's another really excellent graduate level quantum mechanics book, which is Weinberg's book. And to me, Weinberg's book is like orthogonal to Ballantyne's book in the sense that he treats a lot of topics that aren't treated anywhere else. For instance, he's got a treatment of the Eikenal approximation, and he does the canonical formalism, quantization with constraints. No other book does constrained Hamiltonian systems and everything. So that's where he's really strong, and he does a whole quantization, like a non-relativistic quantumization of charged particles in electromagnetic fields and the quantum theory of radiation. He has a very good first chapter, as Weinberg does in almost all of his books, historical introduction, so you can see where quantum mechanics came from and everything. So, together with Ballantyne, I would say these are the two premium, and he has a lot of excellent problems in the book, although they're often one-sentence type problems, and they're difficult. But he, together with Ballantyne, these are the, probably, if you're on quantum graduate level, these are the quantum mechanics books that you probably should start with. Okay, which one is this? Okay, anybody who reads any quantum mechanics books should eventually at some point study Dirac's book, the 4th edition on the principles of quantum mechanics. It's a really nice read, and it will certainly review quantum mechanics, but you'll also see how probably the premier founder, the guy who sort of organized the early developments, and Schrodinger and Heisenberg and Pauli, these guys were all involved, but Dirac sort of invented the language and put it all together, as well as coming up with the relativistic equation and with the start of quantum fields as well. So I highly recommend you read Dirac's book on quantum mechanics. Now, okay, this is an old book. I put this up here. This is one of my favorite books on quantum mechanics. It was by Schiff. It's a classic book. It used to be the standard, him along with Merzbacher. I liked his book to Merzbacher's book. But, there's still some interesting things in here that you won't find elsewhere. And if you're looking for an old-fashioned, straightforward quantum mechanics book that sort of came out of Oppenheimer's lectures and everything, read Schiff, or at least look at it. And now, having gone through all these quantum mechanics textbooks, I want to get to the history and philosophy. And Malcolm Longhair, he has a great book, Quantum Concepts in Physics, where he just discusses the whole historical development. There are several books like this. He does an excellent job, equations and everything, going from quanta, black body, quantum mechanics and everything. And so you, instead of reading the early papers, which are pretty hard to read, if if you're a student, you can read this book. And he also has an excellent book, which I'll put in another playlist, Theoretical Concepts in Physics, where he divides like theoretical physics into like 7 broad areas or case studies. And he sort of like discusses the papers and everything, so it's like Newton's laws, Maxwell's equations, and you often hear about things like Maxwell's equations and how he like developed gears and things like that to understand them. Well, Longhair shows you exactly what Maxwell was doing and everything. And then in thermodynamics and statistical physics, if you want to see how Planck got the black body law and how he guessed and interpolated, it's all here. And then quantization and quanta, like I said, a lot of this chapter and the previous chapter are in the other book on quantum concepts. But also he has sections on special and general relativity and cosmology and particle physics. So I highly recommend both of his books. This is an old book, but a classic book, The Philosophy of Quantum Mechanics by Max Jammer. Today there are many books on philosophy of quantum mechanics, but I think this one is still worthwhile reading, and also look at some of the other books on quantum mechanics and philosophy. Jammer also wrote a classic study on the conceptual development of quantum mechanics, And I remember going to the library to read this. And the thing is, you already have to know quantum mechanics to benefit from this book. But if you've read a quantum mechanics textbook, you can read this and profit. And then finally, my last book, I remember reading a book on quantum theory and measurement. I'll have a lot more books on this, I think, on the playlist. But this is sort of like a reprint volume. It reprints a lot of the early papers. It was published in the early 80s. And it's a good place to start if you're interested in the whole thing on quantum theory and measurement and the philosophy of quantum mechanics. So it's very expensive. Try and get some kind of used edition, because somehow Princeton is like reprinting it and charging a fortune. But so those are the books I recommend on quantum mechanics, and there are many, many, many more that I've left out. There are some that are more advanced, some that are less advanced. These are probably the major ones that I own, that I happen to own, and that are also sometimes often used in American classrooms. But you need to own about 2 or 3 quantum mechanics books, maybe even more, to get a real good understanding of the subject. And right now, like I said, my number one recommendation is start with Barton, Mastering Quantum Mechanics, and then maybe go to Ballantyne and Weinberg on their graduate level quantum mechanics books. So thank you very much for watching, and I'll be back next time updating the playlist on advanced classical mechanics and classical electromagnetism. Thank you very much.